We continue from here. Our S4, some of the first four terms, will give us 160. Now, from this place, 3 raised to power 4 is going to give us 81. Then 2 raised to power 4 will give what? 16 minus 1. Okay? Over our 3 over 2 minus 1. Let me solve this somewhere. 3 over 2 minus 1. I have what? The sum here is what? Is 2. I have 3 minus 1. I have what? Sorry, I have 2. So I have 1 over 2. I have 1 over 2 here. So I don't need to write this again. Let me just write it as what? 1 over 2. Okay? So let's proceed. Our S4 now is going to be 160. So if we go by this one again, so we have 81 over 16 minus 1. So we have 16. Here we have 81 minus 16. 81 minus 16 is going to give me what? 3. 11 minus 6 will give me what? 5. This will give me, that's 65 over 16. 65 over 16. So we have 65 over what? Over 16, then over 1 over 2. So from here, we have 160 times this, we will call this, we're going to give us 10. Okay, so I have S4 is equal to 650 over 1 over 2. Over 1 over 2. So we have 650 times 2. Okay, let me simplify this. Times 1 over 2. So divided by 1 over 2. So on further simplification, 650. Now this one we change to multiplication times 2 over 1. So our S4 is going to give us what? 130. 1,300. So the sum of the first four terms, the sum of the first 4 terms is equal to what? 1,300. It's going to give me 1,300. So from here, I explained how we simplified this, and then how did I get it? 3 raised to the power of 4 is going to give me what? 81. 2 raised to the power of 4 is going to give me what? 16 minus 1. So now when I did this, I brought it out, I did this separately. So and then I found the LCM of this one to be 16. And then 16 divided by 16 times gives me 1 times 81 will give me what? 81. Then 16 divided by 1 will give me 16 times 1 gives me 16. So 81 minus 16 is what? 65. Then over 16. And I brought it back into this place. So then for this one also, the LCM here is what? Is 2. 2 divided by 2 is what? 1 times 3. Gave me what? 3. 2 divided by 1 is what? Is 2. Times 1 is what? Is 1. So 3 minus 2 gave me 1 over 2. Okay? So I brought it down here. So, and from here, 160 divided by 16 gave me what? 10. 10 times 65 gave me what? 650. Okay? Over this 1 over 2 again. So, if there are, now I'm left with what? With 650 divided by 1 divided by 2. If you are doing something like that, our division is going to change towards multiplication. And if it's changing, these 2 will no longer be the denominator. It's going to be the numerator now because we are changing to multiplication. So now 650 times 2 now give me what? 1,300. And then 1,300 is now the sum of the first 4 terms. So let's proceed into another subtopic under this. And that is sum of GP to infinity. Sum of GP to infinity. That is when it is indefinite. Like I told us in AP, when it is indefinite. Okay, so the sum of GP to infinity. Sum of GP to what? To infinity. So now the first question here is the sum of the infinity. Okay, find the sum of the infinity progression. They gave us 3. They gave us 1. So the question is, find the sum of the infinite progression. So they gave us this one as what? The first one is what? 3. They gave us 1 over 3. They gave us 1 over 9. And they gave us 1 over 27 to infinity. That is, it is indefinite. But let's look for the sum of all these to infinity. Now, so let's look at it now. So we're going to be using a different approach here because we are summing to infinity. And what's the formula we use here? We use this the sum to infinity to be a over 1 minus r. All these formulas are very important. You have to know them. Okay? So we have looked at that of n10, we have looked at GP, we have looked at sum, so and the rest of them. But now we're looking at the sum of GP to infinity. So this is the formula we're going to be using here. So now given our a to be what? 3. So you can notice here that our a here is the biggest, so it doesn't have to be the smallest number. Okay, so it's the first number we are seeing here. So our a is what? Is 3. So and then we have our sum to infinity, which is what? Unknown. So our common ratio r is what? T2 divided by what? T1, and that is what? 1 over 3. Okay, so our sum to infinity here, sum to infinity to now give us what? That's a, our is what? 3 over 1 minus 1 over 3. 1 minus 1 over 3. So let's simplify 1 minus 1 over 3 somewhere. We have 3 here, so give me 3 minus 1, that is 2 over 3. Okay, so I have my sum to infinity to be what? 3 over 2 over 3. Like we did in the previous example, I told us that this sign is going to change because we have division and we are changing to what? 2 multiplication. So I have 3 times what? 3 over 2. So what's my answer here? I have 9 over 2, and that is equal to what? 4 over 1 over 2. 4 over 1 over 2. Give me 4 over 1 over 2. As you can see here, sum to infinity from our formula, our a is 3. A is 3, okay? Our 1 still remains 1, and then our r is the ratio, common ratio. That is T2 divided by T1. And I gave me what? 1 over 3. And then from there, so I did the simplification separately, and I got 2 over 3. And from there, 3 times 3 over 2 gave me 9 over 2. And then to mix fraction, the answer gave me 4 over 1 over 2. Now let's look at another example. So the question says find the sum to infinity of the sequence 1 over 2, 1 over 6, 1 over 18. This is quite cheap also. It's a jam question, but it's an OBJ question. Okay, so the solution now, very simple. So our a is given as 1 over 2. Our common ratio is what? Equation 2. T2 minus T1. That is what? 1 over 6 divided by what? 1 over 2. Okay, so I have 1 over 6 times 2 over 1. That is what? 1 over 3. Okay, so our sum to infinity is what? A over 1 minus r. Right? So we have sum to infinity to be what? 1 over 2 over 1 minus, what is our r here? Our r is 1 over 3. Okay? So like we did in the previous one, we have 1 over 3. So our 1 over 3 is going to give us what? 2 over 3. So 1 over 2, let me write it like this, 1 over 2 over 2 over 3. Okay, so I have 1 over 2 times 3 over 2. So that answer is what? 3 over 4. So therefore, sum to infinity is what? 3 over 4. Sum to infinity is 3 over 4. Thank you.